We've looked at solving quadratics by factoring, but not all quadratic equations are factorable. We can use the quadratic formula in order to solve factorable as well as non-factorable quadratic equations. Given a quadratic equation, ax squared plus bx plus c is equal to 0, where a does not equal 0, we can determine the solution, x, which satisfies this equation. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We've used the plus or minus sign before in Math 145 when we looked at error and uncertainty. This plus or minus sign means that x must be evaluated for two different scenarios, once where we use the plus sign and a second time when we use the negative sign. This will yield up to two solutions for x. Let's examine the nature of solutions for our quadratic equation. The number of solutions that we expect for a quadratic equation depends on the discriminant within the quadratic formula. The discriminant is defined as capital D, which is equal to everything underneath the square root in our quadratic formula, b squared minus 4ac. We can evaluate that portion under the square root, and if it is equal to 0, then it means that we will have two real equal solutions. In terms of our parabola, what that means is that with our x-axis, our function will touch the x-axis in exactly one spot, which means that we either have a parabola that opens up and only touch down at the minimum value right at the vertex, or a parabola that opens down and only touches the x-axis right at the maximum or the vertex of that parabola. And that's in case 1, where the discriminant is equal to 0. In the second case, where the portion under the square root is positive, it means that we have two real solutions. So we'll end up having two distinct values of x that are calculated, and graphically this shows as a parabola that opens up but has a vertex below the x-axis, or a parabola that opens down and has a vertex above the x-axis. So in either case, we have two different roots identified, and that is when the discriminant is positive. In the first unit of this course, we looked at the range of a function and the domain of a function. And remember, we talked about what values are possible to go into the square root function. And we're not able to take the square root of a negative number. It doesn't result in a real solution. So when the discriminant, which is the portion under your square root, is negative, we end up with no real roots. And if you're ever looking into future mathematics topics, it won't be covered in this course, but we arrive at complex roots, which are complex numbers. Graphically, what this looks like is we have our x-axis, and we know that our parabola will never touch the x-axis. Therefore, you have a parabola that opens up but begins above the x-axis, or a parabola that opens down and has a vertex below the x-axis. So we can see here, we never cross the x-axis, there's no x-intercepts, and there's no real roots. We're going to look at a few examples where we can use the quadratic formula to solve for the roots of the quadratic equation. I encourage you to go back to the last video and look at the first few pages of these notes and use the quadratic formula to solve for the same questions that we solved by factoring. For factorable quadratic equations, you arrive at the same solution when you solve by factoring as well as using the quadratic formula. Now, in solving all these problems, we know that there will be at most two solutions. And depending on the discriminant, we might find that there are no real roots, one real root, or two real roots. And in addition to those points, in practical problems, there are often some solutions that do not make physical sense. For instance, if we're solving a problem involving time, and we end up with a negative value representing time, we know that that is an inadmissible solution and cannot be the solution to the problem, and therefore you'd only use the positive value to represent that unit of time. So looking at our first example, we want to solve the following using the quadratic formula. Before applying the formula, we should verify that all the terms are on one side of the equation and your equation is equal to 0. And we should also verify, so your square root sign should go over the entire discriminant and your fraction line should go across the entire expression to show what is on the top of the fraction and what is on the bottom. Now plugging in our values for a, b, and c, it's always best practice to substitute in brackets, making sure you take care with your signs in particular and substituting the correct value into the correct places. And one thing we should note is that if you're evaluating minus 10 all in brackets squared, it is not the same as negative 10 squared without brackets. On the left hand side we get positive 100, whereas on the right hand side we get negative 100. So the use of brackets and the placement of the exponent does matter. Now we can simplify our solution for x such that we have positive 10 plus or minus the square root of 196 all over 16. Now we're ready to examine the two solutions for x. We can see here that because our discriminant is equal to 196, which is greater than 0, we expect to have two real roots. So two distinct real roots. For x is equal to 10 plus the square root of 196 all over 16, or x is equal to 10 minus the square root of 196 all over 16. Now we can simplify each of these equations. Values for x, make sure you put brackets around the numerator of the fraction, and we find that x is equal to 3 over 2, or it's equal to negative 1/4. Now that we have two solutions, we can verify that they're correct by plugging them in to our original equation for x and checking that the left side reduces to 0, which is the value of the right side. Looking at part B, we have 9x squared minus 12x is equal to negative 4. But remember, to have the general form for the quadratic equation, to apply the quadratic formula, we must have a quadratic formula that is equal to 0. So we should rearrange, or we must rearrange this equation to be 9x squared minus 12x plus 4 is equal to 0. Now we can identify our values for a, b, and c in the quadratic formula, and we have 9, negative 12, and 4. Alternatively, we could have brought all the terms of our quadratic equation to the right-hand side of the equation, and the sign of our value for a, b, and c would be opposite of what we're using here, but your solutions would be identical. So it doesn't matter which side of the equation you rearrange to, as long as your quadratic equation is equal to 0. Now writing down our quadratic formula, we can substitute the values in, and we can simplify this to get 12 plus or minus the square root of 0 all over 18. We see here that we have a discriminant, so the part under the square root is equal to 0. Therefore, when we add or subtract to 0, we just get the same solution in both cases. So we have two roots that are equal to one another. We can solve for the value of this root, and we get 12 over 18, which reduces to 2 over 3. So you can verify the value of this root by plugging in 2/3 into your original equation, and you'll find that when you plug it into the left-hand side, that it will simplify to be negative 4, just like the right-hand side of the equation. You can also verify these solutions by solving for the x-intercepts of the equation by graphing it in software such as Desmo and verifying that it's equal. We have one more example now to apply the quadratic formula to a quadratic equation before we get to the application problems. And the application problems are why we're using all these solving techniques, so that we can solve various application problems. Example C is 5x squared minus 2x plus 3, and plug in your value of a, b, and c into your quadratic formula. And we get minus -2 plus or minus the square root of -2 squared minus 4 times 5 times 3 all over 2a. When we simplify it, we get 2 plus or minus the square root of -56 all over 10. Note our discriminant is less than 0, therefore we have no real roots, and there is no real solution. In the next video, we'll be looking at application problems of applying the quadratic formula and solving by factoring to solve various application problems.